Hello, this is a video on the binary number systems, and I'm going to take a look at the homework we had recently. And so let's begin talking about number systems, first of all, bases of number system. We use a decimal or a base 10 number system, and we've learned early on that we know there's the ones and the tens and the hundreds and the thousands. Those are S's, by the way, not fives. But we know about exponents now too, and we know that with exponents we can say that this is 10 to the 0. This is the 10 to the 1 place. This is the 10 squared place, or the hundreds place. And this is the 10 cubed or thousands places. So if I have a number like 2, 3, 1, 5, it means I have 2,000 plus 300 plus 10, sorry about my writing here, plus 5. Or I can say, and that's one way of expanded form. Another expanded form way we said was 2 times 1,000 plus 3 times 100 plus 1 times 10 plus 5 times 1. I'm using a touch screen here, so it's sort of messy. And then we learned a third way of expanded form. We learned that we could put 2 times 10 to the third plus 2 times, actually this is a 3, isn't it? 3 times 10 squared plus 1 times 10 to the 1 plus 5 times 10 to 0. We remember that anything to the 0 power is equal to 1. So those are the three expanded forms we used, and that's the base 10 place value system. Okay, so I'm going to get a new screen here, and we're going to talk a little bit more. So I'll trash that. Let me get a little bit darker color here too. How about dark blue or purple or whatever that is? So I'm going to, now the base 10 number system, we know to count, we have 10 digits. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we use only those digits. And with those digits, we can make any number. Matter of fact, once we get past 9, then we go, 1, 10, and 0 ones for 10. Or 1, 10, and 1, 1 for 11. 1, 10, 2 ones. 1, 10, 3 ones. 1, 10, 4 ones. 1, 10, 5 ones. 1, 10, 6 ones. And then 17, 18, 19. When we get to 19, well, we've run out again. So now we're going to have 2 10s, 0 ones. Okay, so we know how to count in a base 10 system. Let's get rid of that again, and let's go into a different base. Let's use, I think we had a problem with a base 5. So in base 5, we don't get to have 10 digits that we make our number one from. We get 5 digits. So we have 0, 1, 2, 3, 4, 5. So we can count. We can go 0, 1, 2, 3, 4, not 5. I just about did 5, but I don't have a 5. As a matter of fact, up here I said I had a 5, and I didn't, so I'm going to erase that. Okay, so I don't have a 5. I stopped at 4. I get 1, 2, 3, 4, 5 digits, but I start at 0, so I don't have a 5. So here I have to go 1, 5. Oops, I'm on my eraser. 1, 5, and 0 ones. I'm going to put some commas here to show that we're counting. And then my next one will be 1, 5, and 1, 1. And then 1, 5, and 2 ones. Now notice that I'm going to pick a different, well, I'll go a little further. 1, 5, and 3 ones. 1, 5, and 4 ones. Now, next one's going to be, I'm going to have to go up 1 here, so it's going to be 2 5s, 0 ones. Let's go one more. 2 5s, 1 1. Now I'm going to pick a different color here. And so I'll pick red. I'm going to count in base 10. Red will be base 10. So I'm going to go 0, 1, 2, 3, 4, 5. Remember, in base 5, the blue, that was 1, 5, 0 ones. This is base 10. The red, it's 6. But that's 1, 5, and 1, 1. Well, 5 plus 1 is equal to 6. This is going to be 7, 1, 5, 2 ones, 8, 9. And this is 10 because it's 2 5s. So 2 times 5 is 10 and 0 ones. This one's 11. It's 2 5s. So for 10 plus 1, 1 is 11. So there's a different base 5. Okay, I'm going to get rid of that. And I'm going to use the simplest base now, which is base 2. So base 2 is often called binary. Bi meaning 2, like, bicycle. So we're going to look at base 2, a binary system. Well, in base 2, we only have 2 digits. We have 0 and 1. So if I'm counting in base 2, I go 0, then 1, and then my next one, I'm going to put some commas there. My next one, I don't have something like a 2, so I'm going to put basically 1, 2, and 1 and 0 ones, and that's my 2. And then I'm going to go 1, 2, and 1, 1, that's my 3. So let me go to a new screen because I think so that gets us counting, but really what we need is we need our place value system like we did with base 10. So let me get a new screen here. And remember how we did 10 to the 0, that's the ones place, 10 to the ones, that's the tens place, 10 squared is the hundreds place, and so forth. Well, I'm going to do the same thing here, but with 2's. So I'm going to go 2 to the 0 is equal to 1. 2 to the 1 is equal to 2. 2 to the second power is equal to 4. 2 to the third power is equal to 8. Remember, that's 2 times 2 times 2. So 2 times 2 is 4 times 2 is 8. So it's not 6. Remember that. 2 to the fourth is 16. Remember our story, 1 grain of rice. We're just doubling things each time. 32. And let's go at least one more. 2 to the 6 is 64. And 2 to the 7th is 128. And I have room for one more. 2 to the 8th is 256. Okay, so I have all those. And let's use this to do the first problem on the homework. And the first problem on the homework was, it had the base 2 number of 1, 0, 1, 1, 1, 0. Okay? Matter of fact, I'm going to erase that and put that in a better place. Okay, good. I erased that. I'm going to put it here. I'm going to write it backwards here. I'm going to put it in a different color. I'm going to pick a dark blue again. So I'm actually going to put it here. I'm going to put 0, 1, 1, 1. I'm going backwards here. 0, 1. So I'm double checking that, and that's correct. That's base 2. Well, they want me to put that in a base 10. But I know, so let's go through that. So I have 2 to the 5th for 32, and I have 1. That's selected there. So 32. I have 0 of the 16, 0 of the 16 here. I have 1 of the 8s, so I'm going to add 8. I have 1 of the 4s, so I'm going to add 4. I have 1 of the 2s, so I'm going to add 2. And I have 0, 1, so I'm not going to add any more. Now I'm going to add all these up. I got 2 plus 8 is 10, plus 4 plus 2 is 16. Carry the 1, and I have 46. So I know that 1, 0, 1, 1, 1, 0 in base 2 is equal to 46 in base 10. Okay? Let's do the next one. And I think I can use a lot of this chart. Let's see how I can erase here. So I think I can use a lot of this chart here still. Oh, it's erasing very nicely. Excellent. Okay, so I'm going to use that same chart I did before. The next problem, and I think I'm still on blue. Yep, still on blue. Good. And so the next problem is they want 9 in base 10. So I have 9 in base 10, and they want that in base 2. Well, I'm going to start with 9 here. So here's 9. And then I'm going to say, will 16 go into 9? So I'm here. No. So no there. Does 8 go into 9? Yes, it goes in once with 1 left over. Okay, so I'm going to put a 1 there because I fit an 8 in there. So I'm left over with 1 now. Does 4 go into 1? No. Does 2 go into 1? No. Does 1 go into 1? Yes, so I'll put a 1 there. And so 1, 0, 0, 1 in base 2 is equal to 9 in base 10. Okay, the next one is another base 2 problem. So I'm going to use my eraser again here. I'm going to erase this. I'd like this, oops, I'm going to have to go back there, right? And so I just messed up one thing there. So I'm going to go back to my pen colors. I'm going to go red, and this was supposed to be a 16 there. So I fixed that. I'm going to go back to my pen colors and pick a blue. The next problem in your book was problem 6, which was 50. So they had 50 in base 10, and they wanted this into base 2. So we're going to start with 50 again. And we're going to say, does 64, I'm here, does that go into 50? No. Does 32 go into 50? Yep. So I'm going to subtract 32. And I get 4 and 10, and I get 8, and I get 18. So I put 1 here because I included that 32. I have a remainder of 18 now. Does 16 go into 18? Yes. So I'm going to put 16 there and do this, do my subtraction. I have 2 left over. Does 8 go into 2? No. Does 4 go into 2? No. Does 2 go into 2? Yes. So I'll put 1 there, subtract the 2. I now have 0. Does 1 go into 0? No, we don't have any of that. So we now know that 1, 1, 0, 0, 1, 0 in base 2 is equal to 50 in base 10. Now on your homework, there was one other one, and that was number 8. I'm going to get a new screen because this isn't a base 2. It says for a base 5. So what it wants is 4, 4, 4, 4 in base 5. They want to know what that is in base 10. And so let's write our base 5. So we got 5 to the 0 is equal to 1. 5 to the 1 is equal to 5. 5 to the second power, or 5 squared, is 25. 5 cubed, or 5 to the third power, is 125. And that's all the digits we need, because our number here is 4 digits. I'm going to change the color here just so you can see some things. Sorry. Here we go. Pressed the wrong button, I think. So I'm going to go to a red again. And so I have this number. Well, I have 4, 4, 4, 4. Well, so what this means, I have 4 times 5 to the third, or 125, plus 4 times 25. Like if this was a 3 here, I would put 3 times 25. Or if it was a 2, I would put 2 times 25, so forth. If it was a 0, I put 0 times 25. I wouldn't, or not include it at all. So the next one is 4 times 5, and then plus 4 times 1. Now I'm just going to add these all up. 4 times 25, 125, let's see, 125 twice would be 250, and then double that again, that should be 500. 4 times 25, that's 100. 4 times 5, that's 20. And 4 times 1 is 4. Now I'm going to add all these up, and I get 4, 2, 6. So I know that 4, 4, 4, 4 base 5 is equal to 624 in base 10. Okay, so that hopefully helps you a little bit with different number bases, binary, and helps you with the specific homework a little bit also. Why is this important? It's important for 2 reasons. First of all, it's an extension of place value. To really understand place value, you should be able to understand place value not only in base 10, but in other bases. It's also interesting historically to know that our base 10 system is somewhat arbitrary. We probably picked the base 10 system because, as humankind, because we have 10 fingers. But it doesn't need to be that way. There's been systems of base 12 and base 60, and if you look at the Babylonians, as you learn in social studies. And then the final way importance is that base 2 binary is very important in computers. Now, you can use computers every day without using binary. You can program language in a high-level programming language without using binary. But at its root, at what the machine is using, what the computer is using, is just zeros and ones. We either have a circuit on or off, so it's telling us whether it's a 0 or 1, or we're making simple decisions as something is yes or no, or true or false. And we can do something called Boolean logic with it. And so it's just simple circuits that are either on or off, or making decisions of something's true or false. And so it's good to have a sense of how computers are doing that. And having a knowledge of the binary system is useful for that. So with that, I'll end this video. So let me close this and stop the recording.